Hey everyone, this is Utavio back with another Korg synthesizer review. I'm not just into Korg synthesizers, but that seems to be what I come across. I decided to start doing some more vintage synthesizer reviews. The last one I did was about a year and a half ago on the Korg DW8000, which was a polysynth from 1985. If you haven't had a chance to view that one yet, go ahead and click. I'll put an annotation on this video right here. Go ahead and click on that video, and I've got a lot to say about that synth. I decided to start making some more of these kinds of videos because I really am interested not just in how synthesizers work, but also the product decisions and design decisions that went into why they were made the way they were made. So just to let you know, the kind of approach to this video is not going to be as much about the sound of the synth, because if you really just want to hear pure sound samples, there's lots of those videos on YouTube. But this is going to be more about how it was made, what design choices went into it, some ideas about how to program it, and kind of delving deeper into what makes this synth unique. So what we have here is the Korg Poly-800. It was made in 1983. It is an all-analog synthesizer. They call it a polyphonic synthesizer. It really, technically, is a paraphonic synthesizer, but more on that a little bit later. This, like I said, is 83. My understanding is Korg made this as a way to somewhat compete with Roland and the Juno series. So what this is it is all plastic, and it does feel kind of plasticky, keeping with Korg's design aesthetics that seems to be carrying over to today. They do make kind of less expensive instruments and less high quality build quality, to be quite honest with you, and it remains true on this thing. It seems solid enough, but it is all plastic. It does have two buttons on either side that you could hook guitar straps into, so you could use this as a keytar, and a lot of people did. So this is kind of classic 80s synth styling here. In keeping with the 80s Korg aesthetic, design aesthetic, they went away from kind of knobs and faders. They said they were going to make it more performance instruments. Really, they made it cheaper by not putting a bunch of knobs and faders on the front, and instead, all your parameters for programming the synthesizer is printed on the front panel, just like the Korg DW8000. And to change patches and to program each patch, you have to use these numbers and these up-down values. So I'll show you what I mean. Right now, I'm on program selecting, so I could select different programs by dialing them in. There's lots of different to choose from. I did want to probably point out at this point that I really am not the best at keys, so don't watch this if you're looking for a really something impressive musicianship. When I make music myself, it's mostly MIDI based, but I do want to just kind of, there's more about how this thing works than good piano skills. So if I want to select a program, and change how it operates, I have to hit parameter mode. And now I can control each parameter. So let's say I want to control the cutoff. That's parameter number 41. So I have to dial 41 and then use these up-down arrows to change it. Yeah, so to be quite honest with you, it's not the best synthesizing experience. Everything is just up, down. Doesn't even have the slider that the Korg DW8000 had. And the other thing that's a little bit of a bummer, you'll notice I have MIDI in already plugged in because I was using other systems to trigger it. But unlike later synthesizers that could use MIDI system exclusive messages, there really is no way to get this thing to respond to computer editing software. It just doesn't exist. All that really is transmitted over MIDI is note on, note off. I think you can transmit program changes, but parameter changes don't respond. CC doesn't respond. There's no NRPRN. it's just pretty basic. This was the dawn of MIDI, not before the band existed. So yeah, this kind of is what it is. It's not impossible to program, and stuff is laid out pretty logically in the front panel, but yeah, it's not the kind of organic experience that a really knobby, slidery synth is going to give you. That's just how it goes. So yeah, you can get up to 8 notes at one time out of this thing, which is, for 1983, for a synthesizer to be able to do 8 notes at a time was actually a pretty impressive feat. I think this went around for just under $1,000 then. It went to me for a little bit, about $100 today, secondhand. Why is it so less? This thing, it does sound very 80s, but to be honest with you, apart from the build quality, it does sound pretty weak. You heard the cutoff slope. And even if I want to mess with the resonance, that right there is another reason why it's not maybe the most popular synthesizer in the world. The constant, these membrane buttons, or just these buttons, they're old, they're 33 years old, so it is constantly giving me, if you hit it once, it reads twice, or it doesn't read at all. It's workable, but it's not ideal, which is why buttons aren't the best way to program synthesizers, but regardless. Another thing that's kind of weird choice is that all the numbers are sitting below the buttons, so you are kind of probably used to telephone keypads and computer keypads, whether on it or, if anything, above it. On this one, they're below it, which seems stupid, but oddly enough, I find my finger keep blocking it, and it's just, I keep hitting a 4 thinking that's a 7, or 1 thinking that's a 4. It's kind of counterintuitive, so that's not too fun. Transition to the sound. Why was the sound maybe it's not really considered a classic synthesizer? I mean, it is old, but it's not really revered like other synthesizers from this time period is. Outside of programmability issues, the sound just is not fantastic, I gotta say. It's interesting, you can get some cool stuff out of it. I will say, I think sometimes people are a little bit too hard on this thing. It is what it is. I mean, you can get 8 voices out of it, 4 if you stack them, which we'll get to in a second. There's some things you can do to make it sound kind of spacey and tripped out, but yeah, the filter, I think, was one of the main problems with it. The filter just really isn't great on this thing. I've got the cutoff down about halfway. I've got the resonance peaked all the way. Let me go back to cutoff. So this should be right about here is where a normal analog synthesizer would start screaming. This just kind of fades into nothing. You can't get anything squelchy. You can't get anything really spiky and bursty and resonant and crazy out of this thing. It's very it's a mild filter. And I think a lot of people, that just simply wasn't what they were looking for out of an analog synthesizer. What I would say, though, it's not, I have to say, not the best for basses. Can you coax it out of them? Yeah. Not the best for leads. Can you coax those out of them? Sure, maybe. But I will say what it is pretty good at are big, kind of mushy strings, pads, those kinds of things. 80s pads, those are the best thing you can get out of this thing. So if you're in the market for that, for $100, and it's collectible, it's kind of cool looking, I think. It's not a bad buy, but yeah, there's definitely limitations. So I'm not going to go into every little bit of how the synthesizer works. I felt like in the Korg DW8000 series of videos, I did go really in detail onto each little part. And really, there's going to be several parts of this video where I kind of refer you to some of those videos, because this actually, coming 2 years before the DW8000, this shares a lot of the same ideas the DW8000 had in terms of how the envelopes work, how the oscillators work to a certain degree. So I explain them in much more detail in those videos, and I'll let you know when those pop up. One of the things that makes the Korg Poly-800 unique in the world of synthesizers is the economic way in which Korg was able to make this synth put out various different kinds of waveforms using cheaper methods. As I kind of mentioned before, Korg's ethos seems to be do the most with the least amount of cost. And they actually did a kind of interesting creative thing with this. So waveforms are simply the way, in case you don't know, waveforms are the way in which oscillators create sound. I'm not going to delve deep into that because I could talk forever about how that works. This video kind of presupposes you know a decent amount about how synthesis in general works. If you don't, click on this video, which is not mine, but it is actually a really great explanation from the ground floor of how does synthesis work. But okay, now that you've watched that, if you're coming back or if you know already, waveforms. It is it's the way again that oscillators make the sound that you hear, and the more complex the waveform that an oscillator is creating, the more expensive it is to manufacture that oscillator. The cheapest and simplest oscillator to make and to manufacture is a square wave, because all it is turn on, turn off, turn on, turn off. It's pretty basic. There's not a lot you have to do. Everything else, sine waves, is coming up and down. Sawtooth is going up, then down. You got trapezoid and various kinds of things. The more complex it is, the more expensive it is. So at the very basic blocks of this thing, you've got square waves. So it creates kind of a spiky sound. Very basic sounding. And it kind of sounds like a toy almost. So that's pretty basic. But you know what's interesting is they do something called, they call it in their manual here, additive synthesis, which essentially you're able to, in order to get a sawtooth, which is basically ramping up, then off, ramping up, then off, they didn't actually create an oscillator that makes a sound or a sawtooth per se. They managed to use a method of oscillators at different junctions to create something like a sawtooth. Creative in that they're using they're basically fine-tuning a very simple oscillator to make a more complex waveform, which I think was actually kind of a cool idea and interesting design choice. So how'd that work? So essentially what's going on is right now I have it set to square waves, but what I can do if I want is set it to sawtooth. Now when it's set to square wave, so I should say when it's set to sawtooth, my waveform sawtooth, you can see and you can hear that it does sound different than the square. Here's square, here's sawtooth. But you also notice that that curve is kind of hairy, steppy, if you will. And that is the, you can kind of see it more as I go lower. That is the byproduct of the way that they accomplish this, which is essentially, you'll notice when you look at the DCO1, so it's digitally controlled oscillator 1, you've got 16 feet, 8 feet, 4 feet, 2 feet. So what is that? That's basically referencing octaves. It's a reference actually to, you see it in a lot of synthesizers, but it's a reference to how organs used to work and the number of feet a pipe had to be to get a certain frequency. So if the pipe is half as long, the note is twice as high. So I have set up various basically steps along the way. It visualizes it in the manual here, but essentially 16 feet is on, 8 feet is on by virtue of the fact that it's 1. 4 feet is on by virtue of the fact that it's 1. 2 feet is on by virtue of the fact that it's 1. So what it is basically creating a step all the way up the audio spectrum and essentially creating a square wave at octaves going up. So it creates something like a sawtooth, though a steppy sawtooth still kind of sounds like a sawtooth. But what's even cooler is I can go in and turn off these lengths independently of each other. So if I want to turn off, let's say I want to turn off the 16 step one. Less steppy and sounds different. Let's say I want to turn off the 8-foot one. Turn to 0. Sounds different. You notice it sounds higher because I'm turning off the longer feet, lower octave note steps, leaving the lower feet higher sounding steps. So I just turned off the 8-foot one. Let's turn off the 4-foot one. And let's turn off the 2-foot one. Now no sound's coming through because not one of those lengths is on, but I could go back and turn back on the 16-foot one. It sounds a lot like a square wave, right? It's because it is. It's only one length representing the whole, so it comes off as a square. But if I come back and turn on the 8-foot one, now it's a little steppier, a little more complex. I'm going to turn on the 4-foot one. And I'm going to turn on the 2-foot one. So yeah, what they basically did is took one square wave oscillator and they managed to figure out a way. I don't know exactly electronically how they did this, but they managed to figure out a way to have the oscillator beating, so to speak, at various intervals down the line and create various steps along the line to create something like a sawtooth. So how is the square wave different than how the sawtooth is done? Well, if the sawtooth creates this sound by taking the oscillator and making it sound at various octaves, if you switch it back to a square wave, it makes each part of the oscillator sound at the same octave. And I think, really, the fact that this oscillator is already set up to be a square wave, but either step it down or keep it all the same, it sounds, even when it's on set to square wave mode, sounds kind of organy at its very basis, which I think is kind of interesting. It's an interesting byproduct to the choices they made here. Just gives it interesting sort of sound down the line once you run it through the amplifier and through the filter. But yeah, very creative way to make your oscillator work. So the next thing I want to talk about is the way in which the voicing works. So I just showed you how right now it's 8 full voices that can come through. It's in whole mode, which means that only one oscillator is being used. There's 8 voices, but only one oscillator per voice. Because right now it is on whole, DCO whole mode, which means like one oscillator per voice, 8 total voices possible. But you can change it to double mode, which means there's going to be 2 oscillators per voice, 4 voices possible. So it's before it sounds like this. In whole mode, in double mode, it sounds like this. Alright, so much fuller, but again, only 4 pieces of 4 notes. So you can hear that essentially every time I put on a new note, it's stealing voices from what was already down. I honestly, when I play with this synth, basically use it in double mode all the time because I think it sounds much better. Now that it's in double mode, you've got DCO2 operating, so now I can go in and change what octave it's in. I can change what the waveform's doing. Right now it's saw, but let's change it to square. Oh, that sounded like absolute garbage, sorry. I can also, just like with the first oscillator, if I change it to a sawtooth, I can go in and affect whether or not all of these different lengths of the oscillator are on or not, which is going to interestingly affect the sound. In addition to that, I can change the level of the second oscillator. I can take the pitch of the oscillator and move it in intervals of notes away from the first oscillator. So what do I mean by that? Okay, let's do this. So let's see, interval, I'm going to do 31. Right now it's bang on. And in this, the higher sounds I believe are going to be DCO1, the lower sounds are DCO2. I'm going to change the interval up. Sounds off, that's because it's one note off. Whatever DCO1 is playing, DCO2 is one note higher. But you can easily dial in fifths here. You can do sevenths, ninths. So very interesting stuff, all the way up to an octave above. And even if it's bang on the same, there's also a detune amount. Disappointingly small number of options here, 1, 2, or 3, or 0, I guess. Bang on. So what detune is doing is slightly moving the pitch of DCO2 apart from DCO1. I'd rather have a chorus like the Roland Junos did, but this is a cheap way, again, that Korg was trying to emulate a chorus effect of slightly different pitches hitting the same notes. Okay, cool, I guess. Again, not as good as a Roland Juno. Sorry, it's not going to be. But you can't get you can't get a Roland Juno for $100 either. So there you go. This does actually have a chorus, but quite honestly, I don't find it very useful. Let's put it with it off. Let's with it on. Off. On. Don't hear a ton of difference. We'll try some other patches later, but I'd rather have a good chorus like the Junos did. But Juno's like $900. Okay, so envelopes. You can affect polarity. You can affect how intense the envelope generating system is. The envelopes use attack, decay, breakpoint, slope, sustain, and release. So breakpoint and slope is kind of different. In most envelopes you see out in the wild, it's going to be ADSR, attack, decay, sustain, release. Breakpoint slope is a lot of on Korg synths. You find out a few other synths. There are good things and bad things, quite honestly. I prefer a synth with just ADSR in it because I find it more useful, but breakpoint and slope does let you have these kind of drawn out changes over time. It takes a long time to explain, and I'm not going to do it here. I actually made a whole video about how the Korg DW8000 does it. Click right here to see that. I'm not going to explain that again. One thing that is interesting about how the envelopes work is that, in a way, it forces you to think about the voices independently. What do I mean by that? So right now I'm in double mode. Let's go back actually for a second to whole mode in terms of how the voices work. So 18 back down to 1 is so pretty thin sounding. What's interesting is since only DCO1 works in whole mode, only envelope generating system 1 is functioning here. This envelope is basically turned completely off because there's no other oscillator working right now. But what's interesting is that if you turn it to whole mode, wow, that sounds like garbage, sorry. Let me put some cutoff on here so it doesn't sound, kind of tame this down a little bit. There you go. Now that it's in double mode, the envelopes are, by design, working completely independently. So you have to address both oscillators completely separately in your mind when you're programming this thing. It makes you be able to do cool stuff with it, like I could make the attack of DCO1 very long and make the attack of DCO2 very short. It sounds like this. So it's creates kind of longer evolving sounds over time. Yeah, I would say that if I'm trying to make a kind of basic patch that's maybe just detune, it'd be great to have some sort of method if it does this, sorry, but I can't figure out a way. If there was some sort of method to address both envelopes at the same time, that'd be awesome. But there's not, so you kind of have to mirror what you do in EG1 if you want to do in EG2 the same. It's interesting. I think it makes you think about synthesis differently. But again, it's more, I think, of a feature of cutting costs than it was about teaching kids how to do synthesis. There is a modulation system over here. Well, of course, you've got your envelope for your filter. Pretty standard stuff. I do want to point out one thing about this, which is that I mentioned before, it's really a paraphonic synthesizer, not a polyphonic synthesizer. What do I mean by that? Essentially, what I mean by that is for a true polyphonic synthesizer means that every voice has a separate filter for every voice. So I could, if one note sounds, the other note sounds totally different than the first one. It goes through its own filter path, 100% separate. Just like any sort of acoustic polyphonic instrument, what you do on one string of a guitar doesn't necessarily affect what the other string of the guitar is doing, unless maybe you want it to. This, all of 8 or 4 voices go through one filter, again, to cut costs. What that basically means is that when you are triggering notes for one filter setting, any subsequent notes that you hit are going to start a new filter setting for all the notes currently being played. Let me show you what I mean by that. So what I'm going to do is I'm going to make the filter take a while to open up for us. I'm going to turn the envelope intensity up. So in this patch, it has a little jump down and then it rises back up, the cutoff does. And if this was a true polyphonic instrument, if I play other notes while I hold the chord with my right hand, the other notes should have their own drop. But what happens is this. So every time I hit any note, the filter settings for every note gets reset. Again, if you're playing big, mushy 80s pads, it's probably not going to make a big difference to you. But if you're doing like sending, I was using Machine to send many different MIDI signals to it, and I noticed it kind of came up, and not in a necessarily good way for me, because I was trying to have different kinds of notes sounding at different times. And yeah, you just have to keep that in mind when you're performing this thing. It's all voices are going through one filter. So there it goes. It does have a MG, is basically 80s Korg language modulation generator. It's 80s Korg vernacular for LFO, low frequency oscillator. You can control it at all times with this keypad, or I should say this joystick. So in addition to bending up, actually let me get rid of this whole thing here. You can control it at all times with this joystick. So in addition to bending up, bending down, you can use bend up to have the LFO or MG control the pitch. Bend down to have the MG control the filter cutoff. Now it's pretty simple. It's very basic. The LFO, you can control how fast it goes. Let's change this, so make it slower. You can change how long it takes for it to kick in. You can even, if you don't want to use the joystick, you can just control it from the top panel. So let's just say I wanted to introduce some oscillator changes without having to use the joystick. Cool and stuff. Seems to be pretty, it's just a square wave. Very simple. You can't control the LFO from an envelope or anything like that, like you might be able to in other synths. Kind of is what it is. Interesting, but there you go. Over here, you got the MIDI, what channel it receives, that kind of stuff. Very basic things. Again, it only receives note parameters. I do want to talk about a couple of other kind of physical attributes of the synth. Um, there's no internal battery to this thing. There were I should say, let me back up. There were many different versions, or several different versions of the Poly-800. This is the earliest version of it. There was a Mark II that came later that had digital delay, which I can't get my hands on, so check out YouTube videos for those sounds. But this one has no digital delay, and this was the first version of the Mark I synth that has no internal battery at all. So when I bought it, it had no presets available. You actually have to put 6C batteries in there for it can run off the batteries, or when the batteries are in there, um, it remembers patches when you turn the synth off. Now, there was a later version of the Poly-800 Mark I that had an internal battery hardwired in there, so you didn't have to worry about putting C batteries in there just to save patches. However, it's been 33 years, so when you look online, you can see a lot of horror stories of people who the batteries leaked and it fried their circuitry. So if you're going to buy one of these things, if you can pony up for the 6C batteries, I'd probably recommend you do that. If it were me, I'd rather check C batteries both with a clip that comes open than have to take the whole thing apart to check an internal battery. And I'm told, I've only had this for a couple weeks, but I'm told that if all you use the battery for is to remember the patches when you turn off the synth, it actually lasts for years and years and years because that takes very low levels of energy. Um, what I did want to point out, which is kind of unique, is that I finally had to learn how to transfer patches by the old tape method. So if you look in the back panel of this, there actually are various different tape uh, inputs and outputs. So in the old days, you could use straight up like a Walkman or a tape recorder. You hit play on the cassette, you enable the synth to receive it, you hit load by doing program parameter then number 1 button. Hit play on your Walkman, it plays this audio signal that sounds kind of like a modem starting up, and that through electronic clicks and buzzes sends the data for all your patches to the synthesizer. Um, don't have a Walkman anymore. I think back in the day, they actually, if you needed to reset your synth, you could buy like a cassette of programs from Korg or other places. Nowadays, you can find the factory patches online. I actually just used like someone uploaded to SoundCloud. I just went off my smartphone, my iPhone, played it, loaded it, seemed to work fine. Um, People have been trading patches that way as well, because there's a way to export patches that way. So you could record it on your computer, just the audio file of what patch it is that you're sending. Very old school, but still works. In addition to loading, these switches back here have a way to affect some interesting features on the top panel of the synthesizer. I'll just kind of go left to right here. So first off, you've got the sequencer. So right now, I've just enabled the synth to be able to take my commands of what to put into the sequencer. When you see the S001, that's basically standing for step 001. I looked according to the manual, it can take up to 256 note events. So that's basically if you have 8 note chords or 4 note chords, that takes up note events. If you just do steps that involve just one single note, it could be up to 256 steps. But if you do 4 note chords, divide that by 4. If you do 8 note chords, divide that by 8. It basically remembers it based on how many notes are being used. And it's very rudimentary, but it sort of works like this. If it works off a system of 16th notes, so if I want to make a 16th note here, actually, I just do this. Taking my finger off the keys makes it go to step 2. Step 3. Now both of those are going to be 16th notes. Let's say the next one I want to be an 8th note. So because I hit step with holding the note down, the chord down, it strung it over 2 16th steps, so 1/8 note. Let's say I want to make the next one a quarter note. I do it 4 times. Now we're on step 10. So now that I've put in some, I don't know what this is going to sound like, but now that I've put in some note information, all I have to do is flip off the switch to disable, then hit start stop. So it kind of is very basic. I did want to point out, like I just did there, you can play along with it. It seems to record not the audio, obviously, that you're playing, but simply records just note data as if someone, like a ghost person, were playing it. And if you have it like I do in double mode, you just heard, I think, how when I play other notes, it steals voices away from what the sequencer is playing. So you can sound bad, or you can mess around with it and kind of have fun with it, make it sound good. I don't honestly think I'm going to use it that much. I just send MIDI notes to it, but it's there if you want to use it. So in addition to the sequencer, there's also a chord memory function. It says chord memory on the front, but what you have to do to get the synth to recognize the chord is hit the hold button, put in whatever chord you want. Hold, by the way, as you just heard, if you keep it down on the hold function, it's just going to hold out as if a ghost were just continuously holding those keys. Sustain and that kind of stuff affects how long the notes actually hold out, but if you keep it on hold mode, it basically acts as if you're always pressing down those keys. Anyway, I pressed down those keys in hold mode, and now that I switch back to chord mode, whatever I put in, whatever notes I put in, it's as if that's the root of another chord. Let's say I wanted a new chord. Now the notes I play. It's interesting. I could see it being useful for house music and that kind of stuff. It's just cool to mess around with. So those are the main features of the Korg Poly-800 that I really wanted to cover with you. Like I say, check out some other videos on YouTube if you want to hear some more sound examples of the synth itself. In the next few videos that I'm going to do with this thing, I'm going to run it through some other tests to see, can we make this thing sound good? Can we use it in a modern context? So I'm going to be doing some things like running it through external filters, run it through external effects processors, that kind of stuff, maybe triggering it other ways. If you have any questions, or if you have things you know about it that maybe I messed up on, you want to correct me, you want to ask another question of me, please leave in the comments below. I really like communicating with people through YouTube, and it seems to be a cool community of people who just find these machines interesting. Otherwise, I hope you consider liking and subscribing, and let me know if you like it, and I'll make sure to make more videos. So until then, keep on rocking, and I'll see you next time.